Welcome to the lesson on trigonometry. What is trigonometry? In Pythagoras' theorem, we learn about the relationship between the sides of a right-angled triangle. That is the sum of the squares of the two shorter sides equal to the square of the longest side. And in Pythagoras' theorem, if we know two sides of a right-angled triangle, we can find the third side. In trigonometry, we will explore the relationship between the angle and the sides of a right-angled triangle. That is, if we know the angle, we can find the sides. And if we know the sides, we can find the angle. We will use the symbol theta to represent the angle. We recall that in similarity, we learned that the sides of an enlarged triangle are directly related to the original sides. We also know that the angles remain the same. So if we take the ratio of the sides in both triangle, say I take the ratio of the sides of these two sides 3/4 in the smaller triangle. When I form the ratio of the corresponding sides 6/8, it will give me the same ratio. This means that this ratio can be used to represent the angle, as the angle does not change. So as long as the angle remains the same, the ratio of these two sides will remain the same. So in the previous slide, we saw that the ratio of the sides can be used to represent the angle. And this ratio is usually written as a decimal. Now, if we have a similar triangle with the same angle, then the ratio of these two sides should be the same as the ratio of its smaller version. Therefore, we can say that x/20 must be equal to 3/4, which is 0.75. And working this out, we have x is 20 times 0.75, giving us x equals to 15. Now, every angle will have a different ratio. So how will we know the ratio for any given angle? Since every angle has a specific ratio, these values can be stored in a calculator. The name of this ratio is called the tangent of the angle. The key is located on the extreme right-hand side of the calculator. And pressing the tangent key followed by the angle, right? The tangent key followed by the angle will give us the ratio. And remember that the ratio is always given as a decimal. Now we will see how we can use the ratio to find unknown sides. So remember that when we know the angle, we will know the ratio of these two sides. So we can write our statement as x/5.2 will be the ratio, which is tangent 50. And then we need to multiply by 5.2 to get x. And in this case here, x is 6.2. Now, since a triangle has three sides, we can form the ratios with the hypotenuse as well. As we can see that there are actually three types of ratio on the calculator: the sine, cosine, and tangent. But to form the ratio correctly, we need to name the sides of the right angle triangle. We already know that the longest side is called the hypotenuse. So the other two sides are named according to the location of the angle. So if the angle is here, then the side opposite to it is called the opposite side. And the side that is next to the angle is called the adjacent side. So now we can form the ratio correctly. Remember, earlier on we see that the opposite over the adjacent gives us the ratio which is called tangent theta. And the other two ratios are formed from the hypotenuse. Sine is the opposite over hypotenuse, and cosine is adjacent over hypotenuse. Now we can remember these ratios by taking the first letter of each part, that is tangent T, then O is opposite, and then A is adjacent. So the first letter is the name of the ratio, and the second letter is the numerator over the denominator, right, for each of this. So we can remember the word tua ka so to remember all these ratios. Now let us take a look at examples. In this example, we must always remember that if we are given one side and one angle, then we can find an unknown side. And we need to identify the side first. By looking at the location of the angle, we know that the opposite side is not known. X is the adjacent side, and this is the hypotenuse. Opposite the right angle is the hypotenuse. So this is where we use cosine, right? Because cosine is adjacent over hypotenuse. So therefore we can form the ratio adjacent over hypotenuse is equal to cosine 60 degrees. And cosine 60 degrees is the ratio of these two sides, and the ratio can be obtained from the calculator. But we need to write it first as 6.5 times cosine 60 and key the expression in this way in the calculator to get our answer, which in this case is 3.25. Alright, in the second case, again, look at the location of the angle. This is the opposite side, so now the opposite side is known, and this is the hypotenuse. So again, we have opposite over hypotenuse is sine, so opposite over hypotenuse, which is y, is sine 40 degrees. Now, how do we do the calculation? We just simply think of sine 40 exchanging places with y. So y goes up and sine 40 goes down. So that's how we can find y, which is 4.2 over sine 40 degrees. And this works out to be 6.53 to 3 significant figure. If we can find the ratio that represents the angle, then we should be able to get the angle from the ratio of sides. And we use the inverse function, the yellow function, which is above the sine key and the cosine key and the tangent key. And we need to press the shift key in order to get this function. So now let us try to get this. Press shift followed by sine inverse and then followed by the ratio in brackets. So you will get the angle 36.8 degrees. Or 36.7, 0.9 degrees to 1 decimal place. Alright, now the angle when you use tangent should also be equal to 36.9 degrees. It's the same angle, right? Using different ratio, but it gives us the same angle. Now let us take a look at an example of how to find the angle. Remember that the first thing to do is to look at the position of the angle, and then we know from here that the opposite side is not known. We have the adjacent side, so we have the adjacent side and the hypotenuse, which we know is cosine. So we have cosine of the angle, put the degrees, equals adjacent over hypotenuse. And we use the inverse function to work out, and this gives us 52.0 degrees. So for angles, it's always 1 decimal place. Now looking at this, the hypotenuse is not known, so therefore it cannot be sine or cosine, but it's just opposite and adjacent, which is tangent. So we have tangent theta degrees is 3 over 4.2, and that gives us the angle 17.0 degrees. So in conclusion, we see that trigonometry is a very useful tool to find the sides and angles in a right angle triangle. We can find an unknown side when we have one given side and one given angle. Like in this case here, we have 5.6 multiplied by cosine 43, which gives us 4.1. And here we can find the angle. If we know two sides, we can find the angle. And here the angle, use the shift inverse function, is 30.7 degrees. And this concludes the lesson. Thank you very much.